So, I've built some pretty crazy stuff in my garage, right? Giant Nerf guns, squirrel obstacle courses, even a glitter bomb package to get back at porch pirates. But what if I told you that some of the most mind-blowing engineering and tech isn't happening in a lab or a garage, but out in the middle of a field? Farming is one of the oldest professions in the world, but it's undergoing a radical transformation. Think less old-school pitchforks and more Iron Man-level tech. We're talking about a world where robots, AI, and satellites are helping us grow more food more efficiently and more sustainably than ever before. It's a genuine high-tech revolution, and it's happening right under our noses, or more accurately, right under our feet. Today, we're diving deep into the world of precision agriculture. I'm going to show you how a little bit of science and a whole lot of clever engineering are solving some of the biggest challenges farmers face. We'll look at how we can use data from the sky and from deep in the soil to make incredibly smart decisions. This isn't just about making farming easier, it's about fundamentally changing the game. We're going to explore the kind of technology that helps a single farmer manage vast fields with the precision of a surgeon. It's about working smarter, not just harder, and the results are absolutely staggering. So get ready, because this is going to be epic. We're going to break down the science behind these amazing gadgets, see them in action, and understand the real-world impact they're having. I've picked out 5 of the most game-changing pieces of tech that are turning traditional farms into futuristic food factories. Trust me when I say, this is the kind of stuff that gets my engineering brain buzzing with excitement. These 5 smart tools will change the way you farm forever. Let's get into it. Alright, first up, let's talk about drones. But forget about those little quadcopters for taking vacation photos. I'm talking about heavy-duty, industrial-grade drone sprayers. Picture this. You have hundreds of acres of corn, and you need to apply a specific nutrient or pesticide. The traditional way involves a massive tractor called a sprayer that has to drive through the crops. This thing is a beast, but it's heavy, and every time it drives through the field, it compacts the soil and can damage the very crops it's trying to help. It's also slow, and if the ground is too wet after a rain, you just have to wait, losing valuable time. It's a classic engineering problem with a lot of frustrating trade-offs. Now let's bring in the drone. This isn't just a gadget, it's a paradigm shift. These drones are essentially flying intelligent tanks. They can carry several gallons of liquid and are equipped with incredibly precise GPS and terrain-following radar. Instead of driving through the field, they fly over it. This means zero soil compaction and zero crop damage. They can be programmed with a precise flight path, ensuring every single square foot of the field gets the exact same coverage, something that's incredibly difficult to achieve with a ground rig that might bounce or slip. And the best part? If the field is wet, who cares? The drone just flies right over it. But the real genius here is the precision and safety. A farmer can target very specific problem areas instead of blanket spraying the entire field. See a patch of weeds on a satellite image? You can send the drone to treat just that 1-acre spot, saving tons of money on chemicals and reducing the environmental impact. Plus, the farmer is no longer sitting in a cab surrounded by these chemicals for hours on end. They can be standing a safe distance away, operating the entire mission from a tablet. It's faster, it's cheaper, it's safer, and it's way, way smarter. It's like having a team of tiny, flying, super accurate farmhands at your command. Okay, so we've all heard about self-driving cars, but what about self-driving tractors? Well, they're not just a concept. They've been a reality on farms for years, and it's all thanks to the magic of GPS. But this isn't the same GPS that's on your phone, which might think you're in the building next door. We're talking about RTK, or real-time kinematic GPS. This technology uses a fixed base station on the farm to correct the satellite signal in real time, boosting the accuracy from a few feet down to less than an inch. Sub-inch accuracy. That's more precise than I can draw a straight line with a ruler. So, what do you do with that level of precision? You hook it up to your tractor's steering system. This is called auto steer. The farmer plugs in the coordinates for a field, and the tractor drives itself in perfectly straight, perfectly spaced lines every single time. When planting seeds, this means every row is exactly the same distance apart, which optimizes the amount of sunlight and nutrients each plant gets. There are no overlaps, which wastes expensive seeds, and no gaps, which wastes precious land. It's the definition of efficiency, repeated over millions and millions of plants. But it goes way beyond just driving straight. This technology guides the tractor during every pass through the field for the entire season. When it's time to fertilize, The tractor follows the exact same inch-perfect lines it planted on, ensuring the fertilizer goes right where the roots are, not in between the rows. When it's time to harvest, the combine harvester follows those same lines again, making sure it gathers every last bit of the crop. The farmer is still in the cab, but they're not white-knuckling the steering wheel. They're monitoring the equipment, managing data, and making high-level decisions. It's like being the captain of a starship instead of just the pilot. We all know plants need water, but how much and when? It's a question farmers have been trying to answer for centuries, often relying on experience, guesswork, or just looking at the sky and hoping for rain. Giving too little water stresses the plants and hurts your yield, but giving too much water is just as bad. It wastes a precious resource, can wash away expensive fertilizers, and can even drown the plant's roots. It's a delicate balancing act, and getting it wrong is costly. So how can we use science to know exactly what the plant needs? The answer lies beneath the surface, with soil moisture sensors. These aren't just simple sticks you poke in the ground. They are sophisticated electronic probes that are buried at different depths in the root zone throughout a field. They continuously measure the volumetric water content of the soil. Think of it like a permanent drinking straw for the field, constantly telling you how much water is available for the plants to drink. This data is then transmitted wirelessly, in real time, directly to the farmer's phone or computer. Now, here's where it gets really cool. The farmer isn't just looking at a single number. They see a detailed graph showing how the moisture levels change over time. They can see exactly how quickly the plants are using water, how deep the rain penetrated after a storm, and most importantly, the precise moment the soil reaches a stress point where the plants need a drink. This data can even be automated. The sensors can talk directly to the irrigation system, telling it to turn on in a specific zone, apply a precise amount of water, and then shut off. It's a closed-loop system that gives the plants the perfect amount of water exactly when they need it, without wasting a single drop. Imagine being a doctor responsible for millions of patients spread out over hundreds of acres. That's essentially what a farmer does. They have to spot problems like diseases, pests, or nutrient deficiencies early, before they spread and wipe out a whole section of the field. Walking through every row of a massive field is physically impossible, so small problems can easily go unnoticed until they become big, expensive disasters. This is where the power of artificial intelligence and computer vision comes in. It's like giving the farmer a team of super-powered assistants who can check on every single plant simultaneously. So how does it work? We use high-resolution cameras, often mounted on drones or even tractors, to capture detailed images of the entire field. These images are then fed into a powerful AI model. This AI has been trained on millions of pictures of plants. It knows what a healthy cornstalk looks like, but it also knows the subtle signs of nitrogen deficiency, the specific blotches of a fungal disease, and the telltale bite marks of a specific insect pest. It can analyze the images and pinpoint problem areas with a level of detail that the human eye could never achieve from the edge of the field. The AI then generates a health map of the field, color-coding areas based on the type and severity of the issue it detects. A farmer can look at this map on their tablet and see, okay, there's a small patch of northern cornleaf blight starting in the northwest corner, and it looks like some Japanese beetles are popping up along the eastern edge. This allows for an incredibly targeted response. Instead of spraying the whole field with a fungicide just in case, they can treat that one specific spot, saving money and minimizing chemical use. It's proactive, not reactive. It's plant healthcare, powered by artificial intelligence. After a long season of planting, watering, and protecting the crops, we finally get to the main event harvest. This is the moment of truth where all that hard work pays off. In the past, a farmer would harvest a whole field, weigh the total grain in the truck, and get an average yield for the entire area, say 200 bushels per acre. But an average can be misleading. It hides the fact that some parts of the field might have produced 250 bushels, while other parts only produced 150. You know you have high-performing and low-performing areas, but you don't know exactly where they are or why. This is the problem that yield mapping tools solve. Modern combine harvesters are equipped with a yield monitor and a GPS unit. As the combine moves through the field, the yield monitor continuously measures the amount of grain being harvested at any given second. The GPS records the exact location of that measurement. By combining these two data streams, how much was harvested and where it was harvested from, the system creates an incredibly detailed, color-coded map of the field. It's like a performance review for every single square yard of soil. This map is pure gold. A farmer can lay it over other data maps, like soil type maps or fertilizer application maps. They can see, wow, this low-yielding area lines up perfectly with that patch of sandy soil, or this high-yielding strip is exactly where I tried that new seed variety. It turns the entire field into a massive science experiment. It provides the hard data needed to understand what worked and what didn't. This information is the foundation for all the planning for the next year, allowing the farmer to make smarter decisions about what to plant where, how much fertilizer to apply, and how to manage problem spots to make the next season even better. It closes the loop on the entire precision ag process. So there you have it. Drones that act like robotic farmhands, tractors that drive themselves with inch-perfect precision, sensors that let us listen to the soil, AI that acts as a plant doctor, and maps that give us a report card on every inch of our land. This isn't science fiction. This is the reality of modern farming. It's a beautiful symphony of biology, engineering, and data science all working together. The goal isn't just to use cool tech for the sake of it. It's about solving real-world problems. It's about being better stewards of our land, conserving our resources like water, and reducing our environmental footprint. The challenge of feeding a growing global population is one of the biggest we face as a species. And the answer isn't just about finding more land to farm, it's about getting more out of the land we already have and doing it sustainably. The tools we've looked at today are at the forefront of that effort. They empower farmers to make decisions with a level of insight and precision that was unimaginable just a generation ago. It proves that innovation can happen anywhere, and some of the most impactful engineering is happening in the quiet solitude of a cornfield. It makes me optimistic about our ability to solve big problems when we put our minds to it. This is just the beginning of the agricultural technology revolution. New tools and even crazier ideas are being developed every day. If you found this as fascinating as I did and want to learn more about how technology is shaping the future of agriculture, there's a whole world to discover. Explore more on www.agric4profits.com. Don't forget to subscribe. Thanks for watching, and we'll see you in the next one.